Hi everyone, my name is Janani and my teammate is Saurupya. Today we are going to present our final year project titled is Paddy Leaf Disease Classification, supervised by Vishnu Kumar.
Abstract. Accurate detection of paddy leaf disease is a complicated task that farmers encounter throughout the maize development and production phases. We will be utilizing TensorFlow for deep learning and the CNN architecture. We present a real-time automated method for detecting paddy leaf diseases based on the CNN architecture. The suggested system's advantage include security, interpretability, high accuracy, a lightweight model, and rapid processing, and its performance does not degrade with time. It has the potential to be utilized in the future for real time disease detection on the paddy leaf and is easily accessible to botanists and researchers for research purposes. Introduction. Paddy disease identification is a prerequisite for efficiently and precisely preventing paddy disease in a complex environment. The rapid expansion of smart farming has resulted in the digitization and data driven detection of plant disease, allowing for better decision support, analysis, and planning. Deep learning algorithms are still being developed, but they have made a substantial contribution to the identification of plant diseases, giving a reliable instrument with extremely exact results. The number and quality of label data used for training, however, has a significant impact on the accuracy of deep learning models. These are the literature survey that we refer, and our base paper title is Disease Identification in Paddy Leaves Using CNN Based Deep Learning. Scope of the project. The scope of this paper is to implement and investigate how different CNN methods impact the prediction. The scope in our research is to split this class into disease affected images and normal images. This can be classified into classes. Besides, extracting handcrafted features from raw images after different processing is one of the best scopes we have worked in this research. The objective of using this method is to get some features which are specifically responsible for paddy disease prediction. In the existing systems, our paper is based on ANN and are found to be less accurate and almost incompatible with most datasets and applications. Although prediction results achieved are promising, these traditional approaches are still far from being highly accurate and efficient. The existing systems are simple and effective but are extremely vulnerable to impact. Moreover, state of the art methods can predict outputs pertaining to certain parts of the plants, while while some pest infestations may go completely undetected. In the proposed system, our paper is an automated real-time system for plant disease detection that uses CNN architecture. It has been trained on synthetic and real images using transfer learning to classify the input into categories of diseases. The advantages of the proposed system are secure interpretability, high accuracy, lightweight model, and fast processing, which are desired in plant research, and its performance does not deteriorate with time. The software requirements are operating system program Windows XP, programming language Python, tool is Anaconda with Jupyter Notebook, framework Keras, and hardware requirements are processor is Intel Core i3 or above, ROM is 180 KB or above, RAM is minimum 2 GB, Windows 7 or above. Architecture diagram. Architecture. So first, we have collected the images of paddy leaf that contain disease and healthy leaf stored in database. We give input to image pre-processing. After analyzing, we will resizing the images, change the alignment and cropping and rotation. After this, we are removing the noise from images. Then we build CNN model. In this model, it will classify whether the leaf is affected by disease or not. Then we need to save and train the model. Then the output will be given to user. Now my teammate Janani will continue the rest of the PPT.
UML diagram. In UML diagram, we are using sequence diagram. In sequence diagram, there are three models. User algorithm training model. User gives the input to the algorithm. The algorithm already has a built-in CNN model with labeled images. Model is already trained. The trained model is able to do an image processing, noise removal, and EDA. After the analysis, the trained model user output gives an output to the user whether the leaf is affected by disease or not. It's able to predict the disease whether it is affected or not. Data flow diagram. In data flow diagram, we have data sets which contains affected leaves and healthy leaf. We send that to an image processing. The image processing analyze that is it do a noise removal and EDA. After that, it labels of images to classify whether it's affected or not. Then, using that extraction, it builds an CNN model. After that, we train the model and we can give the input to the last model whether it able to analyze whether the leaf is affected or not. Modules. We had three modules: data collection and pre-processing, implementation of CNN, prediction and testing. Data collection and pre-processing. The process begins by setting up the environment and compiling the data. Data collection is done via datasets. The data is collected by importing the necessary libraries from source websites. After the data is collected, the quality datasets are labeled accordingly. Pre-processing of data is performed where missing and null values are dropped in this process. It is followed by another process where the images are being assigned. Next module is implementation of CNN. CNN classifies have four steps, namely convolution layer, activation foundation, max pooling, fully connected network. Here we use a ReLU layer. ReLU layer is used as a rectified linear unit is used T scale. The parameters to non-negative values. We get pixels values as negative values too in this in this layer, we make them as zeros. The purpose of applying the rectifier function is to increase the non-linearity in our images. The reason we want to do that is that images are naturally non-linear. The rectifier serves to break up the linearity even further in order to make up of linearity that we might impose an image when we put it through the convolutional operation. Next is the pooling layer. The pooling layer reduces the height and width of the images, helps to reduce the computation as well as help makes feature detector more invariant to its position in the input. The process is what provided the convolutional neural network with the spatial variance capability. Next, the full connector layer. The role of artificial neural network is to take this data and combine the features into wide variety of attributes that make the convolutional network more capable of classification images, which is the whole process from creating a convolutional neural network. In convolution layer, 3 into 3 kernel is applied on the input matrix with straight 1. So that size of the image is reduced, obtained matrix is sent to the activated layer. Here, a ReLU activation function is used to eliminate the negative values. The next step is max pooling. Here, the rectified maps goes through a pooling layer. Pooling is down scaling operation that reduces the dimensionality of future map. The output of this layer is matrix with reduced size containing all the features. Next module is prediction and testing. This is the final module. The train module is used for predicting the output. The input image will be given by the user and the output will be predicted by passing the images to the train model. Train test split evaluation. The train split is a technique for evaluating the performance of machine learning algorithm. The process involves taking a data set and dividing into two subsets. The first subset is used to fit model and is referred as the training data set. The second subset is not used to train the model. Instead, the input element of the data set is provided to the model. Then predicts are made and compare the expected values. The second data set is referred as the test data sets. Result and discussion. This page shows the result and discussion of the our project. It shows an effective net model. In this, we built a model to train and test the sets. It shows the inspective 3 model. In the we built a model to train and test it. This model is created. This shows an CNN model. In this, we built a model to train and test it. Results. As after analyzing the three neural network, namely conduit inspection efficient net v2, we found out that efficiency net v2 model shows promising results compared to other two models. The results are analyzed based on accuracy and loss value. The accuracy rate and the loss value of inception model is 95% and 36.7% respectively. The efficient net v2 model is saved and using the web app to serve the users need of detecting the paddy disease through image of paddy leaf output. When the user needs to upload the disease image of predicting the disease affected in paddy leaf. Once the image is uploaded, it shows this page. Then we need to click the predict button. Then it shows whether the leaf is affected or not. Conclusion. Paddy disease increase agricultural productivity, putting the food supply at risk. As a result, early detecting of this illness leads to significant increase in crop output. Crop disease can be discovered by examining the structures of leaf images for destruction. Our proposed method improves diagnosis accuracy and is significantly useful to the subsequent strategy. This results will uh, aid in the detecting of paddy crops infected with disease. These are the papers we have referred for this project. Thank you.